Thanks very much. My name is Rick de Ruiter. I work for the SAS IoT Product Innovation and Engineering team. And today we will be talking about powering AI agents with SAS AI and real-time analytics via MCP, the Model Context Protocol. I'll start my presentation by briefly explaining what MCP is all about. And after that, we'll be looking at how you can create your own MCP tools and apps in SAS event stream processing. After that, we will have a look at a predictive maintenance use case with a live demo, and we'll be spending most of our time on that part today. In the end, I will give you a brief summary of what we have learned, as well as how you can get started with this technology. LLMs have two major flaws. So once LLMs are trained, you can't really ask any questions outside of the scope that they were trained on. Also, LLMs cannot really act on their own. For that, they need access to tools. Tools like databases, search engines, or real-time analytics. And this is where MCP comes into play. MCP bridges the gap between LLMs, AI agents on the one hand, and tools on the other. It's a standard way for LLMs to call tools. See it as the REST APIs for LLMs to call tools, if you will. Now, for today's demo, we will be creating an AI agent for an operations engineer. But this operations engineer will not have to deal with all of the technical complexity that's happening under the hood. He will make sure that the operations engineer can ask meaningful questions. What we don't want is to create a system where the operations engineer has to ask questions like, get the latest events from window W underscore something something. That's not what we want. We want the operations engineer to be able to ask meaningful questions. Questions like, okay, what is the latest battery status? Or ask that question in German. Or help me to find out which batteries need replacements, or even schedule these battery replacements for me. Or what if XYZ changes? These are the types of questions we want to help the operations engineer with. Now, for that, we are going to use SAS ESP, Event Stream Processing. ESP is SAS's real-time streaming AI inferencing engine, and it allows you to, without having to store it first, at very low latency and very high throughput. Because it's built on ESP, what we're going to do, that means that all of it is very up-to-date, because we're working with real-time data, but it also means that the projects are governed, versioned, and deterministic. So we're giving the LLM access to all of that. What we are going to do in the process, when we set up MCP tools in ESP, is that we are going to add semantic descriptions, both to the tools as well as the variables that we are going to use. And this provides the LLM the right context of when to call which tool and how. And that makes sure that we can really tailor it to our own operations, so that we get the benefits of interacting in natural language with all of the benefits of using real-time analytics. That really gives you the best of both worlds. Now, let's zoom a little bit in on the MCP tools itself. So, as I said in the beginning, MCP tools are a bit like REST APIs for LLMs to call tools. And just like REST APIs, MCP tools can return text, JSON, images. And MCP tools have been around for quite a while now, and are supported by all the major GenAI clients, like SAS Retrieval Agent Manager, but also ChatGPT, Claude, Mistral, Visual Studio Code, and many others. And since this year, you can develop your own MCP tools in ESP. How it works is, if you have developed this MCP tool, you can ask questions like, what's the yoga pose? And then send a picture along with it. The LLM will recognize that it has a tool available to do pose estimation in this case, and it will actually see that the LLM is going to make a call to ESP. ESP replies back what kind of key points it found, and then the LLM does a final interpretation of, okay, this must be the Warrior 2 yoga pose. This is how powerful that combination is. There's a new kit on the block as well called MCP apps. This was released in January. And the cool thing about MCP apps is that you cannot just return text, images, or JSON. No, you can actually return mini apps back to the GenAI client of your choice. It's already supported by Visual Studio Code, but also Claude and ChatGPT. And you can build really cool visualizations using ESP, but also work with maps, forms, and so on. And what you see today is a sneak preview of what's available in ESP, and we hope to release this very soon. Now for today's super demo, we are going to look at a predictive maintenance use case. In Carry, we have a flood prediction solution that consists of a network of sensors. And all of these sensors are powered by batteries. But we always want to make sure that this critical sensor network is working, such that we need to make sure that we timely replace these batteries such that we get data from all of these sensors. For that purpose, we have developed a predictive model that's going to predict the voltage of all of the batteries in 30 days' time. If you have a look at the voltage over time of a battery, and you see that the voltage of these type of batteries is pretty high in the beginning, and at a certain point it starts to drop off, and when it gets below 2.5 volts, the batteries get unstable and the sensor can go down any minute. What we're interested in today is the situation where the current voltage is above 2.5 volts, but the predicted voltage in 30 days' time is below 2.5 volts, effectively giving us 30 days' time to replace the battery. Now, what I've already done is I've already developed an ESP project to look at all of this data. So I'm already ingesting the sensor data, I'm adding some features to it, I'm running an Onyx LSTM prediction model to get the voltage in 30 days' time, and at the end I do some aggregations. But now let's see how we can set up MCP tools in this project. What you see here is called ESP Studio. It's a low-code interface to develop your ESP projects. On the left-hand side, you see what we call windows. See those as building blocks to transform your data as it comes in. On the right-hand side, you see project properties. And now what we have added is a section called Model Context Protocol. As you can see, I've already set up a number of tools here. Let's open the first one. This tool is called Get All Sensors. This will help us to get all of the sensor data, as well as the predictions. This is an MCP tool of type query, so that means that it's going to fetch the contents of one of these building blocks in real time. But there are also other types that you can use, like scoring to score AI models directly with MCP, but you can also use subscribe and publish to get data in and out of ESP. And finally, there's also an option to build your own custom MCP tools using either Python or Lua directly from ESP Studio. The next thing that we have to do is provide a title and a description. And this has to be a meaningful description of what it is about. And this is used by the LLM in the end to know what it is all about. We have to give descriptions to each of the variables as well. So for each of the variables that we have in our data, I said, okay, what is this all about? Now I've set up a number of other tools as well as 2 apps. But maybe to make this a bit more concrete, let's have a look at how this will look like for an operations engineer. So let's save this project and add this to our LLM. The process differs for every GenAI client, so I've already set it up. I'm using Visual Studio Code today. But now the LLM has access to real-time data and AI from ESP. Now let's first ask it a question like, show me the sensor data as time series. So now the LLM is going to reason what kind of tools and apps are available. And now it picked the MCP app to visualize the data in real time. So here you see an MCP app in action. As you can see, we're working with real-time data. Now let's ask a different question, like show me the sensor data and predictions as a table. So now likely what it's going to do is use a different tool, probably the one that we saw before, to query all of the sensor readings. As you can see, it's made a call to ESP here. And now we're presented with a table with all of the live data from ESP. And as you can see, there's one sensor that requires service. So this is the battery we need to replace in the next 30 days. What we've done so far is interact with the system in English, but we can do it in almost any language. So I don't speak Spanish, but I prepared something. So what I can do is also ask the same question in Spanish. And this is very relevant, especially in manufacturing, where we have many workers who don't speak English, but they can just interact in their own language with these kind of systems. I can't really check the outcome, but it seems like it's still the same sensor that requires service. But for now, let's go back to English. And let's remember this sensor. Another cool thing about MCP is that you can actually mix and match different MCP servers. So far, I've been using the LLM together with ESP. But what I can also do is, for example, add a different MCP server, like a Jira ticketing service, so that I can directly create a service ticket to replace this battery. So let's say, OK, create a Jira ticket to replace the battery for sensor, and then our sensor ID. And now what's going to happen is the LLM is going to fetch the data for this sensor, and it's going to add this to our Jira ticket, such that someone can go out there and replace this battery. We'll loop over the different Jira projects. And there we have our Jira ticket. We can also open it in the browser. And as you can see, we have a real Jira ticket such that this battery can be replaced. Now, before I am going to replace this battery, maybe I also want to show the data on a map. I can do that as well. And again, we will be seeing the live data situation as it is. So it was one sensor that required service, and apparently it's over here. I can also ask different types of questions, like what-if scenarios. So maybe I know that the weather is getting hotter, so maybe I can see what influence that has. So let's ask a question like, what if the temperature of our sensor is, let's say, 15 degrees Celsius. Sorry, I'm from Europe. So what's now going to happen is that the LLM is going to fetch the current data for this sensor. It's going to change the temperature to 15 degrees Celsius, and it's going to rerun our prediction. Let's give the LLM some time. And as you could see, it has quite a bit of influence on the prediction. So it was like 2.5 volts right now, and in 30 days' time, we predict 2.68 now with a higher temperature. So this really helps you to understand what influences these types of systems as well. And the cool thing is that you can really stay in control and know what's going on, because you can really see what happens in every step. So this is the input that was sent to ESP. This is what ESP replied back with. And I could go on and on with these kind of examples, but for now, let's go back to the PowerPoint. What I've showed you is how easy it is to create your own MCP tools and apps directly in ESP. By adding these meaningful descriptions to the tools and apps, you can really make sure that it works in an operational context. Because it's all working with ESP, that means that you have access to up-to-date information, it's governed, it's versioned, and it's deterministic. And of course, predictive maintenance is one use case where this is useful, but there are tons of use cases out there where you can leverage this technology. If you are just as excited as I am about this technology, please go to your ESP Studio installation, click on View Example Projects, and then search for MCP. There you will find an example of how you can get started with MCP yourself. If you have a use case that you would like to discuss with me, please do come visit the AI for Smarter Operations booth at the front of the Innovation Hub, or visit sas.com/ESP. A huge shout out to all of these people who made this possible, and thank you very much. Are there any questions for now?
Fantastic. First, before we get to questions, a quick round of applause for Rick. Came all the way from the Netherlands, and you're ahead of schedule, which is a rarity. So thank you.
And we have time for questions.
We do have time for questions.
So we're exploring using MCP currently with trying to connect Claude to SAS Via right now. One of the questions we have is if we submit a command to the AI to make like a data set or something through the MCP protocol, who does it say created the data set on the other side? Like, does the MCP somehow mark its ownership, or is it the person that uses the MCP, or?
So what happens inside the MCP server is like a technical account usually that's going to process the data, but you can set up some governance and authorization on the different MCP tools.
Thank you, Rick. Any other questions? We still have some time. Nothing? We have to charge you for the second one.
Is ESP free with Via, or is it another package we have to add on, or?
It depends on what you have bought specifically. In some Via packages, you have ESP with it as well, but it depends on what you have bought. But we can have a look at what you have available in your environment.
Is there an opportunity to add real-time data or streaming data, or is it just flat files?
So you can connect with any system. So for example, at our booth, we have industrial PLC systems. And we can read all of this data via OPC UA protocols, for example. You can ingest all that kind of data into ESP. You have tens and tens of different connectors, as we call them, to ingest data from third-party systems.
Perfect.
Thank you. How do you configure multiple MCP server? How do you configure multiple MCP servers with, let's say, ESP?
So what you do is in your GenAI client, you can specify the MCP servers that you want to use. And it depends on your GenAI client how you can add these MCP servers. For VS Code, it's a matter of adding a URL, usually. So you add your instance of ESP, and you're good to go.